Welcome to Click Academic. This is lesson 7 on the series Mathematical Method. We will be discussing about Maclaurin series. Example 3 under Maclaurin series. We are asked to find the Maclaurin series for f of x is equal to ln x plus 1, where n is equal to 4. Solution. We are asked to find the Maclaurin series for f of x is equal to ln x plus 1. So as we said, you should differentiate the function up to the desired function, but in this case we are restricted the number of derivatives. We are to stop at 4th derivative. This n is equal to 4 implies that you are to stop at 4th derivative. You should differentiate it 4 times. Therefore, the first derivative of the function f of x is equal to derivative of ln x plus 1 is 1 divided by x plus 1, but multiplied by the derivative of the bracket. And derivative of x plus 1 is 1, because derivative of x is equal to 1, and derivative of 1 is constant, derivative of constant is 0. Therefore, derivative of x plus 1 is equal to 1. This is equal to 1 times 1 over x plus 1 multiplied by 1 is equal to 1 divided by x plus 1. The second derivative. So to find the second derivative, this function is in fractional form, so you should apply quotient rule. But to avoid quotient rule, we can take this x plus 1 from denominator to numerator, and it will take negative power of 1. So before we find the second derivative, we can say this f prime of x is equal to x plus 1 raised to the power minus 1. Then we can differentiate this function by applying chain rule as we differentiate this one. Therefore, the second derivative is equal to, remember, to differentiate is power multiplied by the coefficient, then reduce 1 from the power. Therefore, the coefficient here is 1. Therefore, minus 1 times 1 is negative 1 into x plus 1. Then reduce 1 from the power, negative 2. Then third derivative, f prime prime of x is equal to minus 2 times minus 1 is plus 2 into x plus 1. Then reduce 1 from the power, minus 3. Then fourth derivative of x is equal to minus 3 times 2 minus 6 into x plus 1. Reduce 1 from the power, negative 4. Remember, from the formula we are looking for f of 0, f prime of 0. So we have to replace 0 instead of this x. Therefore, this f of x should be f of 0 is equal to ln x plus 1, and remember we are replacing 0 instead of x, therefore 0 plus 1, which is equal to 1. Then f prime of 0 is equal to 1 divided by, remember x is 0, anywhere we have x now is 0, so 0 plus 1, 1. Then f prime prime, because this f prime of x, we already substitute the value of 0 in there. Therefore, f prime prime of 0 is equal to minus 1 into 0 plus 1, because x is 0, so 0 plus 1 is 1 raised to the power negative 2. Then f prime 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 of 0 is equal to 2 into x is 0, 0 plus 1, 1 raised to the power negative 3. Then fourth prime of 0 is equal to minus 6 into 0 plus 1, because the value of x is 0, 0 plus 1 is 1, then raised to the power negative 4. Let's bring this one down. Then our f of 0 is equal to ln 1. Ln 1 is equal to, that is log 1. Log 1 is equal to 0. Then f prime of 0 is equal to 1 divided by 1, 1. Second derivative, f prime prime of 0 is equal to minus 1 multiplied by 1 raised to the power negative 2. So we have to take the power first. 1 raised to the power negative 2 is equal to 1. Then multiply by 1, negative 1, because 1 raised to the power anything is 1. So 1 raised to the power negative 2 is 1. Then 1 times negative 1, negative 1. Then f prime prime of 0 is equal to 1 raised to the power negative 3 is 1. Then 1 times 2, 2. Then 4th prime of 0 is equal to 1 raised to the power negative 4 is 1. Then 1 times negative 6 is negative 6. Then from the formula, remember, f of x is equal to f of 0 plus f prime of 0x plus f prime of 0x squared plus up to infinity. But in this case, we are asked to stop at 4th prime, so f, let's say n prime, then of 0 x to the power of n divided by n factorial. We have to stop at 4th derivative. Therefore, our f of x now is equal to f of 0. F of 0 is equal to 0 plus f prime of 0, which is equal to 1, then multiply by x, plus f prime of 0 is equal to negative 1, then x squared, divide, sorry, I forget over 2 factorial here, so divide by 2 factorial, plus after second derivative, then third derivative, and the third derivative is equal to 2, multiply by x to the power of 3 for the third derivative, divide by 3 factorial, plus fourth derivative is negative 6, so negative 6, multiply by x to the power of 4 for the fourth derivative, divide by 4 factorial. So let's open this bracket. Our f of x is equal to 0 is nothing, so plus times 1 plus 1 plus 1 times x is x. Then plus times negative 1 is negative 1. Negative 1 times x squared, negative x squared, divided by 2 factorial. Plus times 2 is plus 2. Then plus 2 times x cubed is plus 2x cubed. So plus 2x cubed divided by 3 factorial. Then plus times negative 6 is negative 6. Negative 6 times x to the power of 4, negative 6x to the power of 4 divided by 4 factorial. So we can stop here, and if we like, we can find the value of this factorial. So let's simplify it further. Therefore, our f of x is equal to x minus x squared divided by 2 factorial is equal to 2, plus 2x to the power of 3 divided by 3 factorial is equal to 6, minus 6x to the power of 4 divided by 4 factorial is equal to 24. So since we have 2 here and we have 6 here, they have common factorial. So now let's reduce the numbers. So our f of x is equal to x minus x squared divided by 2 plus 2 in here, 1, 2 here, 3. So is x to the power of 3 divided by 3 minus 6 here, 1, 6 here, 4. So x to the power of 4 divided by 4. That's all.